Record. Okay, so welcome. We're recording. Welcome, welcome. Thank you so much for joining us. I'm Tom Paper, Vice President of the California Map Society, and my wife Eleanor is here with me. I'm here with Paul Rosin and Irene Testini and Julia Thomas of all of Cardiff University. So thank you so much for joining me. I'm super excited. We're here because a gal named Sara listened to a tweet on mine and connected me with, there we go, connected me with the project that you guys are working on. So again, I'm super excited by what you guys are doing and wanted to, Eleanor, maybe you want to sit.
It's okay.
No, you're connected. You
connecting.
It says he's connecting.
Let's see here. Oh, okay. All right, hold on. All right. All right. Try as we might. Can you type in the 415 number? Okay. So let's just get started. No, we're not gonna restart. So tell me about the project. What's the genesis of the project that you are working on?
Well, the project we're working on actually goes back about 20 years, really, into the first research we started to do into using digital methods to explore and interrogate illustrated books. So that's our subject matter. We're really interested in illustrated books, particularly 19th century illustrated books, because that's really where you see the global expansion of illustration as a mode of representation. So we're interested in all the little pictures that you see in those historical books. They cover a vast array of different genres. So you see illustrations in travel books, works of science, philosophy, history, literature. And it just seemed to us that these images in books tended to be marginalized in both scholarly research and also in a digital environment. So a digital environment, in a sense, had made them more accessible in that they were mass digitized, or at least the books were, because most mass digitization projects were really interested in the text rather than the pictures. So we came to these projects on the basis that even in a digital environment, pictures in books, illustrations in books were in a sense rendered invisible because there was no way of actually searching for them, or at least searching for them in terms of what they contain, the actual subject matter itself, their iconography, whether they contain pictures of geographic locations or people or customs. All this was lost because there was no way of actually searching image content. So that was our motivation, really, and we began 20 years ago with a very small database, which was called the Database of Mid-Victorian Illustration. And in that particular project, we did the digitization ourselves. So we digitized around about 900 images that appeared in works of literature in the middle of the 19th century. So that's the website there. It's still available online, actually coming up to its 20th anniversary. So it's looking a bit old there, but it's still perfectly functional. So you can have a look at that and a browse through that. And it basically contains around about 900 images. And our intervention here was not just actually digitizing those pictures, it was attempting to make the content of those pictures searchable. So with this database, we tagged them all by hand. So that meant actually looking at each picture and creating a list of words that describe the pictures so that users, the end user, coming to this site would be able to type in a keyword, like cats or dogs or whatever it happens to be, and would find images that contain that subject matter. So in terms of the computational processes themselves here, I suppose you could say it's a little bit primitive now in that we were tagging these things by hand. But the problem, as we sort of progressed over the years, we wanted to do this sort of research with more images.
Yeah.
So we had 900 book illustrations here. But what happens when you suddenly got 1 million? Because we know in this sort of period of global expansion of illustrated material, there are millions of illustrations being published every single year.
Right.
So how on earth do you make the content of those pictures searchable in any sort of useful way? So that leads us on to the projects that we have done since. I don't know whether would you like me to go into detail, or have you got more questions?
Yeah, no. So you started with the database of mid-Victorian illustration, and then you went to something called the Illustration Archive?
We did. So that was our next big project. I should say that these projects were all funded by the Arts and Humanities Research Council in the UK. So we were very, very lucky, really, in that we got sort of money, the funds to do this. But we did make the case quite convincingly that actually the book illustrations were the part of the book that seemed to be sort of rendered invisible in a digital space. So with the Illustration Archive, we are dealing here with over 1 million book illustrations. Now, these had already been digitized for us. So Microsoft did the digitization of these books back in the early 2000s. It's a British Library collection of books. So Microsoft went into the British Library stacks and they scanned their way, across the stacks until basically they ran out of money. So they managed to get 68,000 volumes, which is pretty considerable. And the interesting thing for us is that within those 68,000 volumes, there are over 1 million book illustrations. Again, the book illustrations were not the thing that the digitizers were setting out to capture. It was really the words. They wanted to scan those words and get them OCR'd so that they could be searched. The illustrations were just a byproduct, but for us, they were in a sense the most valuable byproduct. So this is the data set that we're working on, books from the British Library. And with the Illustration Archive, our main aim was to create a digital database that was searchable and that could search across 1 million illustrations. So we used a variety of computational methods to get these images searchable. The main one of which in this particular incarnation of the project was crowdsourcing. So we used a crowdsourcing infrastructure, and what this means is that we ask the user a number of questions relating to the image. So again, this is a publicly accessible website. It's on there, so if anybody wants to give us a hand and tag some of the images for us, please do. There are lots of questions there. So you basically, as a user, you drill down through the image. It asks you what's in this picture. And the idea is that we collect all this information so that those pictures then become more searchable to end users. So that's what we were doing really with the Illustration Archive. When we started out on all these projects with illustrations, there was no way in which computer vision tools or, artificial intelligence, whatever you call it today, machine learning, could do any of the searching for us, so we're talking about 20 years ago when we were manually tagging these pictures to make them searchable. The technology just wasn't really up to it. So as we've gone along, we've wanted to sort of experiment with the latest computer vision tools to see if actually there is a way of computers making these images searchable in terms of what they actually depict.
Okay. So now we're on the doorstep of this project. Okay. All right. So launch us into that, please.
Okay. So the latest project, which again is funded by the HRC and the NEH in the States. This is a collaboration with the University of Wyoming. And this uses the same data set as the Illustration Archive.
Okay.
So it's still those British Library illustrated books. But what we're interested in here is how can the latest developments in computer vision help us to find and to analyze illustrations of places and the people associated with those places. Because we know that in this British Library data set, we have a very rich collection of, for instance, travel books,
Right.
guidebooks, travel books, and lots of images of places that can't be searched according to those places. So we're interested in, will our computer vision technology allow us to find, for example, illustrations of Cardiff Castle, or of San Francisco, or of, University of Wyoming? We're interested in the Wild West. So can we find images of the Wild West, of cowboys, of indigenous populations?
And how do you get around this need to tag everything?
Right. So this is where we have we're using computational methods in order to do that. So I don't know, Irene, whether you want to talk about the sort of thing that we've been doing.
Well, the first step was to get the captions, like we said, and we didn't need to manually tag anything, because there are some models that are already available for document layout detection. The problem with those models is that they are trained on data that is completely different from our data, so we had to work around it. So the way we did it was we used two separate tools. We used the tool for identifying the actual illustrations, and then we used a model called Layout Parser for document layout detection that is capable of scanning for text. Now we can't isolate the captions, but we just made some assumptions there about where the positioning of the caption would be and what the length would be. And we extracted from all those text boxes that the layout parser finds, the boxes that were below the image and that were not too long. And we actually have got a lot of captions out of that. We've also got false positives, so bits of text that are below an image but are not actually captioned. But for the sake of the stage of the project that we're at right now, that was still good data for us, because it did allow us to at least find extra information rather than exclude potential captions. So that was one of the things that we did. The second stage is the actual object detection. So there's a lot of models that have been trained on object detection already, but they've all been trained on photography, mainly, like actual pictures.
So this is like find a castle or find a...
Yeah, so object detection, if you're given a scene, a picture with a few things on it, for example, a beach with and like a parasol and a person, and then a sea there with a boat. Object detection model actually identifies objects and draws boxes around them. And it tells you that there's an object there,
right? And
then it tells you what object it is. Now the categories are not exhaustive. They have been trained on a lot of categories,
right?
But you're not going to find every single thing. So, and also, like I said, the problem is that they are trained on pictures, and there is a problem within computer vision that is called the cross depiction problem, which is actually the problem of using object detection on some artistic depictions rather than photography. And there's been some studies that show that it seems to be that computer vision models pick up on texture more than they pick up on shape. So when the texture changes in the picture and it's no longer photography, but it is a painting, an etching or something like that, it struggles to find those same shapes that it found in photography. So what we're trying to do right now, we are employing what's called the neural style transfer. So neural style transfer was actually very popular a couple of years ago, just as an internet thing. It became a trend. They are models that are capable of turning an image in the style of another image. So you feed it a picture of your cat and you feed it a picture of a Van Gogh painting, and it gives you back your cat as a Van Gogh painting. So we are currently using a data set for which we already have tags. It's called the COCO data set. It's a data set used in computer vision training. It's a data set of more than 100,000 images that have been tagged already. And if they got the bounding boxes with categories, I think it's about 90 categories ranging from like objects to people and things like that. And we're turning these images in the style of our images in the hope to retrain the model to then recognize the texture of our images.
So how do you describe the dream scenario of the project? Like what, like if you could wave a wand,
Yeah.
what would happen?
The dream scenario.
Yeah.
Now, I don't think this will actually happen because I don't think that computer vision is quite there yet.
Mhm.
But what I want is a scenario where, as a user, I can go into the illustration archive and, okay, put in the search word castle and find all the castles. I think we might get to the stage where we can sort of do that.
Uh-huh.
But there is something else here, which isn't just about finding objects. It's about analysing the connections between those objects. So I'm interested, for example, and our partners are interested in ways in which castles have been represented over time in the Welsh landscape.
Yep.
So it's things like, how do you sort of trace visual connections, maybe across time, from, say, one castle in a 17th century illustration to another castle in the middle of the 1920s, the sort of 20th century,
Yep.
20th century, mid-20th century photograph.
Same castle?
Could be the same castle, or it could be even more advanced than that, is in terms of the sort of iconographic representation.
Yeah.
What would be the nearest castles to a particular representation? Because it could well be it's not that castle at all.
Yeah.
Maybe iconographically, a castle in Wales, its iconographic features are more or less identical to a castle in south of France or wherever it happens to be.
Yeah.
So it's sort of what I'm most interested in is how you can use computer vision to actually analyze and interrogate patterns, iconographic patterns. And for me, that would be historically. So through time, how have things changed? You know, and what we see in these illustrated books, in a sense, is the creation of what we would today call stereotypes. You know, especially when you're dealing with things like illustrations of people and places.
Yeah.
And you look at Indigenous populations, the way they have been represented. I mean, we're here in Wales today.
Yeah.
You can look at how Welsh people have been represented. And really those book illustrations, because they were the dominant media of the time, they put in place stereotypes that we carry with us today. And, you know, they can be very political, or it can be something very simple, like, you know, those areas today that we choose to take tourist photographs of, all that comes from, you know, the perspective that people adopted in the 19th century. You know, so where people stand, where the tourists stand, where they go, you know, that's all there in these images. So it makes it really important to actually analyze how those images are what they are and how they have developed into something today. So that, I think, is far more complex in computer vision terms. So it's not just a matter of finding a cat, although that's crucial. That's the crucial first step, is you have to find the castle.
Right.
But then it's how can you use those tools to actually trace patterns and to make connections between things. We can do it with our naked eye. Right. You know, but you can't do it with a million images. So maybe Paul has some ideas on that, actually, on how that could work.
That's all right, Paul, go ahead.
So as Julia and Irene said, computer vision has made great advances in the last 20 years, but you know, you start off with just a bunch of pixels, and an individual pixel really has got very little information. You know, there's nothing there. What we really want to do is, from a high level point of view, be analyzing what we call semantics, which is meanings of things in the image. So it's not all about pixels, it's about objects and their meanings. And so it's really said, just a simple thing like computing the similarity between two things is immensely difficult. Even if I, for instance, were to have two images, say two images of two castles, and to compute some number that represents how similar they are, well, we can't do that properly. We can do it after a fashion, but it's really more about looking at, you know, this pixel looks like this pixel and this pixel looks like that. It's not telling you really
Right.
Similar are they in a sort of
Iconic?
sensible, iconographic sort of manner? You can try to extract out various features, maybe there's some lines, some patterns, some textures, but it's really very early stages.
Well, why is that such a hard problem? One of the questions I wanted to ask you guys was, I'm familiar with how AI can now make images. It seems like if you ask it to make an image, it can do that so easily, but recognizing images is hard. Why is that such a...
mentioned earlier on today about natural language processing.
Yeah.
It's also a very challenging task. But if you think about the difference between NLP and vision, NLP as a starting point has words. So already you've got these units which have meaning to them.
Yes.
I mean, maybe an individual word hasn't got a lot of meaning, you need a sentence, but nonetheless, you've already parsed it. You're already starting with these elements which have meaning. Whereas, as I say, in images, we just have pixels. A pixel has no meaning.
Yeah. So Irene, you were talking about the three components of computer vision, right? The pixels.
Oh yeah, I was mentioning how
Can you share that again?
The images are seen by a computer.
Yes.
Yeah, so you have pixels and you have them in 3 matrices, one after the other, and then when you're going through a deep learning model, at the first stages, you can think about the fact that it's picking up on just the position of certain pixels.
Yeah.
And then as it goes along, it's picking up on features like corners and angles and lines. And then at a later stage, it makes up more complex shapes and more complex colors. But even though it's doing that, it's not learning the actual meaning of
the
a single
image.
pixel or of a single line. It is just putting together pixels that have got a certain value, like a number. But the difference between the way we do it and a computer does it is that we actually have a material experience of things.
Humans.
Yeah, we humans have a material experience of things. There is an embodiment in our knowledge that a computer doesn't have, which is why recognizing images is easy for us, but it's not easy for a computer, because for a computer, it is just pixels. For us, a tree, we know what a tree looks like and we don't need to see a million trees to know what a tree looks like. We know what a tree looks like after seeing about 4 of them. And like Paul was saying, when it comes to words, it is a little bit easier because you can encode words within a computer. So a computer learns the encoding of a word and it learns a representation and it corresponds to that specific word.
Yeah.
Whilst a tree does not always look the same in terms of pixels within an image. It might be in a different position, it might be in a different color, it might not be the same tree. It's definitely not the same tree across millions of pictures.
Right.
So there is no such thing as a tree from a computer representation, whilst there is the word tree from a computer representation. Now, a lot of those image generation tools that you've seen, they actually rely as well on the natural language processing aspect of it. They translate text to image, and they've learned to translate text to image because they've been shown text and image at the same time. Whilst in our case, and in a lot of computers,
they're just showing the image.
They've just got access to the image. They might have a label, but a label is not an explanation. It is just a label.
I can maybe give an example of the difficulty going back a bit, comparing 2 images. Imagine we've got an image which is just a checkerboard. So white, black, alternating white, black pixels. So if I have this image and then I take another version where I've just shifted all the pixels.
Black, white now.
So yeah, I've shifted them all 1 pixel to the right, so they're alternated.
Yeah.
So now if I compare these 2 images, pixel by pixel, a simple algorithm would say they are the most different pairs of images possible.
Yeah.
But of course, if we were to look at them, we would say, yeah, checkerboard, they look pretty similar. So it's showing you the difference between just measuring pixels and actually having some sort of understanding of what the images represent.
Isn't there some aspect, is there a tool out there that helps with the conceptualizing of, because our brain, I think, can look at details, but some of the concepts that we're talking about now, I don't know the black white thing. I don't know if you could recognize that if you're looking at a big image, but is there any computer equivalent to generalized thinking about an image?
I'm not quite sure exactly what your question is.
Well, I'm hearing you say that computer vision is dependent upon seeing things at the most basic level, at the pixels, at the features, at the what was the other color, and that you start with that. But isn't there another aspect to this, which is,
Well,
what is
It's
this?
interpretative, which is
Well,
exactly.
right, and
but
maybe
the-
I can't. Maybe I'm trying to describe something that doesn't exist.
I mean, that's what
Yeah.
computer scientists are working towards, giving computers the ability to generalize concepts.
I mean, we
and
look at-
not just
Look at what we have on the screen here, right?
yeah.
I have a map, right?
Yeah.
We all look at it, we know it's a map. Now, whether a computer could look at this and know that it's a map,
so
I don't know.
One way of interpreting the deep learning approach, which is very popular now, is you have a whole series of layers. You start off with an image, you get spread into one layer. That layer feeds the value into another layer, and you keep on going. You might have 100 layers, or even 1,000 layers.
and do the layers understand layers of
Well,
what are
they're just numbers.
Yeah, that
Numbers
complex mathematical
Numbers multiplying numbers and
Okay.
numbers. It's just that each layer is doing another step of this adding and multiplying.
yeah,
And you start off the very first pixels, the very first values are pixels. So that's what the layer is storing, the pixels.
yeah,
And as you go through these layers, one way to look at it is that each layer is somehow extracting out some features from the data. And as you successively continue along, the features are becoming more and more complex, more and more high level. And ideally, when you get to the end, there should be some sort of high level concepts.
yeah,
You know, it's getting there to a degree, but it's not cracked it yet.
yeah. It seems very I mean, it seems very challenging. I mean, I think about a Bruegel or a painting that you can look at it in detail, even these things. I mean,
But just imagine any real object. It has an infinite number of possible appearances, depending on even just changing the lighting,
yeah.
but never mind changing the position of the object.
yeah,
There's
some
an
of this,
infinite number of possibilities.
something reminds me of the problem of finding the distance of the coastline of Britain. This is a fractal related problem that
Yeah.
that if you, are you familiar with this
I am
problem?
I don't think it's the same problem.
It's,
I
well,
don't think
let me make my case.
Right.
I mean, there's a conceptual level. When you look at this map and I measure the distance of the shorelines here, it's one thing. But then if I zoom in far enough, it's a different problem. So what I guess what I'm saying is that with images, there are things that you see at a zoomed out level that are very different from what you see at a zoomed in level.
I think from a computer vision point of view, a non-expert always is surprised at how difficult we seem to be finding it and think, well, you know, we've been at it for 50 years, what's the problem? But, you know, my answer to that would be, you can see things and understand what you see, but it's a purely, as it were, unconscious process. You cannot introspect and work out how you did it and explain it to me.
I'm fascinated by this question. I've
So-
asked.
So if I ask you to give me a method of recognizing this pen that will work in any situation,
Yeah,
you can't do it. At least I don't think you can do it.
I don't know. I'm going to say it's that pen. You mean the blue and clear pen, or the
It's got to work.
or that it
different
is a pen?
positions, different lighting, different backgrounds.
Yeah,
Maybe have a bit hidden.
yeah.
Plus, maybe there's a lot of other pens that look a bit similar, but they're not that pen. So you've got to discriminate.
Okay, so this seems like as good of a chance as any to segue into AI versus machine learning, because I asked about this. I guess maybe I'm too susceptible to what's going on in the public now, and that I'm buying into this narrative that, yeah, that what is it? Generative AI is going to control the world, but does AI does AI have a role to play in computer vision, or am I using the wrong terms?
So there's something called, they like to call it GeoFAI, good old-fashioned AI. That's what we had back in the day. And that's a standard term. You'll see it everywhere.
Uh-huh.
So when I started off, that's what it was. And people came up with lots of like rule-based systems where you write down lots of rules about how to process some data. You might have heard of some of the ones like medical stuff, where people would input their symptoms and they'd have a bunch of rules derived from expert medics, and they would apply these rules and come up with a diagnosis. But it was always difficult to scale up. You know, we've been talking about scaling up. How can you scale up to cover all the possible cases? And then that has sort of been bypassed now with all this machine learning. So machine learning is one of the tools that AI is using. But there's actually a new thing that's coming out recently. I'm not totally familiar with it, which is called neural symbolic AI. And what they're trying to do is have the best of both worlds.
Uh-huh.
So they're trying to take the traditional constraints and knowledge and somehow combine that with all the machine learning. So machine learning does a good job in many ways.
Yeah.
The old stuff also worked quite nicely. You could clearly, explicitly tell it what you wanted. You could give it some rules and say, this is the rules, follow these rules. With the machine learning, it's just about throwing data at it and you hope it's going to learn the right thing.
Uh-huh.
But maybe we can combine these two things together. But that's very much ongoing new research.
Yeah. Huh.
And unfortunately, outside the scope of this project, I
Yeah,
would say.
unfortunately, yeah.
But I think what is one of the most interesting things for me as a humanities person,
Yeah.
who's been involved in these sorts of discussions, I can't say that I understand them from a technical perspective.
Yeah.
But what I am interested in is the way that the very problems tell you something about the images themselves.
Mm.
You know, and how they can actually be interpreted.
Yeah,
So-
like going back to the castle example,
Yeah.
like Paul was saying, the moment you change the lighting or you turn the object a little bit,
Exactly. It's something
it becomes
different.
difficult for the computer vision model to recognize that's the same object, which makes it really hard, for example, to track iconography across time and across different books, because it might be the same picture of the same castle.
Yeah, exactly.
But if it's colored in a different way, or if it's turned slightly, if the picture's been taken from below and not from like the back,
Yeah.
then we are capable of filling in the gaps.
A bit of ivy goes up the wall, no
Uh-huh.
problem.
No problem.
Not for computer vision, for humans.
Yeah. No problem. Right.
Yeah, we are capable of generalizing and filling in the gaps. We know what's behind the building without having to walk all the way around. But a computer vision tool needs to know exactly what it's looking at to be able to recognize it. And the slightest change makes a very big difference. So yeah, tracking change across collections becomes very hard.
So generalization is one of these big words nowadays that people are using
Yeah.
in all this machine learning, because it's one of the main challenges, generalization.
Yeah.
I'm just letting
Oh.
letting our viewers say hi to you. I'm sorry if I'm repeating something that all the people like who've encountered computer vision have already said to you, which is that this is really hard. But I'm thinking about that pen in the castle and the ivy on the castle, and just asking myself, why is this so hard?
So humans use all sorts of heuristics,
Yeah.
even though
Yes.
you're not even familiar with
Yeah.
heuristics.
Yes. No.
So I'll give you an example.
Yeah.
There's a famous sort of illusion called the Thatcher illusion. So I guess even from the US, you know who Margaret Thatcher was.
Yes.
And so it shows you this picture of Margaret Thatcher upside down. And you turn it the right way around. Do you know this one?
Yeah.
You turn it the right way around, and it's really scary because her eyes and mouth have been cut out and are pasted upside down. But the bizarre thing is that when you see it first upside down, you don't notice it. Now, you know, why is that? And the reason is because evolutionarily speaking, we have developed
Yeah.
as cavemen
Yeah.
and cavewomen to
Yes.
recognize faces upright.
Yes.
So it's an evolutionary advantage to quickly recognize upright faces and less advantage to recognize upside down faces. So that's a sort of heuristic that's used in our visual processing to help us recognize things, but you weren't aware of it. So you were doing it, you are doing it, you could do it, but you don't know you're doing it.
Yeah. So are these all things that computer vision is trying to mimic or build into
Well,
its
the interesting thing with
capabilities?
deep learning is you just throw in the data and you don't know what it's going to do and how it's going to do it, and it
Yeah.
may have mimicked it, but it's famous for taking what they call shortcuts, the
Yeah.
easiest route to success,
Yeah.
which might solve the specific problem for the specific task, but unfortunately it doesn't generalize, and therefore when you try it out on some new examples, it breaks down.
Yeah. So are you saying that deep learning is, are you skeptical of?
It's got its
I'm
flaws.
a bit skeptical, but one solution is just have more data. So, you know, we have data sets now with this one called ImageNet, which has, I think it's 12 million images that
Yeah.
have been manually categorized. And that's a huge amount of work,
Yeah.
manual work, but that's seen as the way forward. Just put more effort into it.
It does assume that manual tagging itself is a purely transparent, objective activity. when actually it's not. I mean, going back 20 years to our original project, Database of Mid-Victorian Illustration, where we were tagging everything by hand, made us aware of the fact that actually that is always a political act. You know, what you describe in an image and what you leave out. So the assumption is, you know, with manual tags, that it's just a purely mechanical process.
Well,
the point is that these manual annotations and these big data sets for these deep learning models are deployed and employed for tasks that don't necessarily require any ethics or humanities behind. Like if you're training a car to not hit people, you just need to tag for people and trees and fire extinguishers and things like that. So the humanities aspect of it, the questions around why that's called a certain thing and not another is not necessarily important to the task.
But there's a huge amount of interest now in machine learning bias.
Yeah.
You have conferences dedicated in the last 5 years to machine learning bias. And so with these big data sets, there is now a big push actually to try to make them, I guess, less biased is the word.
Yeah.
So for instance, with this machine learning, with this big data set, they're saying, well, hang on, it doesn't actually have many images from Africa or wherever. And therefore it's sort of marginalizing, you know, even just, you know, fruit from Africa or people from Africa or houses from Africa. So now there is an effort to try to ensure that these data sets are geographically representative across the world.
Yeah. I want to take us back to part of the conversation that Julie and I had about the project. And she mentioned to me, and I'm going to go to my questions here, that OpenAI's CLIP is part of the project.
We'd like to employ it, yeah, soon, yeah. So CLIP is a multimodal model. So it learns from both text and image simultaneously. That means that it can learn representations of objects across different contexts, thanks to text and not just what's in the image. So we're hoping that because we have captions and images, that even though the captions might not contain words about certain images, if those objects have appeared in other images and they were mentioned in those captions, they should be able to be picked up across images anyway.
That's your hope, is that adding your images to the larger set of images, that there may be...
The good thing about CLIP is that you don't have to retrain it.
Yeah, this CLIP has been trained on some enormous data.
Yeah, you don't need to retrain it.
I don't know how big it is, but I think it's probably bigger than millions.
4 billion.
So you won't be, so your data will not be training it, you will be using it. Is that more accurate?
Yeah. We could partly retrain it, but I think it requires a lot of computing power, and I'm not even sure if we got the facilities.
These guys, they have huge workstation farms. They train for months on end. So that's only big corporations can do that sort of thing, Google and Facebook and so on.
Yeah. So you're going to use CLIP to try to see if it can help you understand what's inside your images, what they say about all these images.
Yeah, because so CLIP is trained by feeding it all of these images with captions. So I think the database has been harvested from the internet, so a lot of captions. And they might not be exhaustive, but there is also a lot of data. And the way it works is every time you feed it an image and the text that it comes with it, it learns an encoding, so machine representation of the image, and therefore the elements within the image and the words in that caption. So it doesn't just learn an encoding for just an object, but it learns it related to the context of the scene, and when it comes to the word, related to the context of the sentence. And then the way you can use it is you can just pick some words that you might want to find in your data set of images, and you feed it to CLIP, and CLIP will give you back whatever text encoding it produced for those words through the training process. And it will also look for images that have that same encoding that was associated with the text encoding of that word, and therefore give you all the images. And there might be images that you were surprised that they were included. You know, there might be, I don't know, a lot of dogs on a bed in a corner that were not even mentioned to begin with. So that's what we're hoping to find, especially because the captions are not exhaustive. Captions, and the object detection models that we are trying to use are also not exhaustive when it comes to some of the objects. Like, for example, all of that Wild West, there's a lot of iconography in that it's not been tagged in object detection models before. I'm pretty sure your ImageNet doesn't have a lot about cowboys.
Right.
Because these 4 billion images were taken from the internet, there's a good chance that there were a lot of cowboys at some point in the data set. And we might be able to identify our cowboys things to play.
Yeah.
ImageNet has 1,000 categories, but I don't know if it includes cowboys.
Yeah.
Okay, I'm going to take us back and go a little broader. I'm going to jump back to some of the top of the list of questions. So how did you find the University of Wyoming, and are there any other collaborators in the project?
Yes. Well, we found the University of Wyoming because Cardiff has actually recently signed a strategic agreement with Wyoming. But it happened to be the case that I was in contact with an historian there. So it's another humanities PI in Wyoming. So we've got, because this project is really about using computational methods to take these book illustrations into cultural institutions. That's the key. So what we're arguing is that cultural institutions, museums, galleries, libraries don't tend to use book illustrations, for example, in their public engagement activities, exhibitions, and for the simple reason that there are so many of them, they are vast, and they can't really find, they don't know how to find what they're looking for. So that's really where we began, is how do we encourage more libraries and museums to actually use these book illustrations in terms of the narratives they tell. So that's really why we wanted to use these computational methods. So our partners are University of Wyoming, as I mentioned, but we're also working with Lambeth Palace Library, with National Trust in the UK, and with the Buffalo Bill Museum, which again is it's Wyoming based. Right. So as you can imagine, the sort of materials that these cultural institutions would be interested in, it varies widely. Yeah. You know, the Buffalo Bill Museum, completely different in terms of the objects they contain to, for example, the National Trust House in North Wales. So because these book illustrations, we know, contain such a variety of information, we know that actually they've got a relevance in those different places. But how do we enable those cultural institutions to actually find the pictures that will be useful for them? So that's what we're trying to do with this project. And that's why we're focusing really on people and places, because lots of those cultural institutions are interested in telling a story about where they are, you know, geographically.
And how would this differ from, I mean, what do they do now when they want to find, or when they want to find images? They Google Buffalo Bill and
Google. I mean, the other thing we want to do, of course, is to put their objects in connection with our book illustrations.
Their objects.
Exactly. So that new narratives and stories are by the sort of juxtaposition of the two.
And so those are your, that was my next question, was about target audience. So libraries, museums, galleries.
Museums, and of course the other target audience then is public engagement. So it's how they actually engage with their public.
With their public. And what about students at Cardiff and
students
things like
at
that?
Cardiff, I mean, they've always been involved in these projects, really, and basically through courses that we teach specifically on illustrated books. But there is certainly an educative dimension to everything that we do, really, because we want to educate people about the significance of, you know, the history of illustrated books.
Monetization, is there any, I mean, this is a cost an event that costs. It doesn't necessarily
Yes.
bring back any revenues, I'm assuming.
That's correct. I mean, there's no sort of commercial enterprise. It's a purely
Yeah.
academic enterprise that's funded. As I said, we've been lucky that all our funded projects have been funded by the Arts and Humanities Research Council in the UK, and this one by the National Endowment for the Humanities as well.
Tell me a little bit more about when we were at lunch, we were talking about projects that start and stop and start and stop. If that's got to be is that a challenge here that you're trying to?
It's a challenge. I think it's a challenge for anybody who's working on sort of funded projects like this, which is, you know, it's terrific to have the funding and have the resources to be able to do this.
Yeah.
But they're always fixed term. So it's usually, you know, this particular project is 36 months. Previous projects, I mean, the Illustrating Archive, we did in 15 months. It was very short in terms of duration.
Yeah.
So they're always fixed term. And at the end of the project, of course, your team goes on to
something else.
Jobs, various posts elsewhere. So there is a sustainability issue involved.
Yeah.
With all of these funded projects, which isn't ideal. I mean, we do what we can.
Yeah.
But then things just stop, and then you have to get more funding to carry on, and you know,
sometimes the outputs are somewhat lost. A lot of websites
exactly have disappeared.
Disappear, because you can no longer sustain it and pay it.
Exactly. So it's the issue of digital sustainability as well. So we've been lucky with the database of mid-Victorian illustration. I said we're about to celebrate its 20th year, but that really is an exception to the rule. And the reason that's lasted so long is because in terms of the actual computational infrastructure, it's very simple. I mean, it's just sort of an access database, I think, at the sort of back end of it. So it didn't require any sort of elaborate technology, but the Illustration Archive actually does, because that's hosted on, because it takes up, images take up a lot of space, a lot of memory.
Right.
So that particular data set is hosted by Advanced Research Computing at Cardiff University, which is basically supercomputers. Because that's
the size of the data set
size
itself.
of the data
How
set
many
needs,
terabytes it is.
You know, and all this does cost money.
Yeah.
So we're constantly, this is my sort of, I'm always grumbling about the fact we're always trying to get money from here and there to ensure the sustainability of these resources. And so many, you know, I've met people who've run projects over decades and they've fallen by the wayside. You know, they just disappear. They've even disappeared offline. I mean, nobody's maintaining them. Licenses aren't renewed. They disappear.
Yeah.
So it's a real problem with basically with the funding situation with, you know, projects in not just the UK, this is sort of USA as well.
Computer vision is as a practice area or subject area. Is that you know, are there other projects like this going on that you guys are aware of?
So in the digital humanities realm of computer vision,
yes and no. I mean, there must be other ones outside of digital humanities, but how about in digital humanities?
I mean, when it comes to digital humanities, computer vision has been very involved lately. There's a lot of really cool projects. I mean, there was that project by, I forget his name, Thomas.
Yes, Smiths. Now he worked on 19th century newspaper illustrations.
Yeah, and photography, war photography as well. He did a lot of work on that.
That's right.
And he was using computer vision tools to do clustering of the images, and then making a case about the fact that the photography that has been the war photography that has been put out to the public was handpicked, and a lot of the media depiction was incorrect, and there was a lot more iconography in that war photography that was not uncovered. And he used computer vision tools to cluster these images into families of iconography, and showing which ones were more likely to get exposed to the public and which ones were actually not made public. Now they are public, they do exist, but the people were not made aware of them. So that was a very interesting one. There are a lot of projects.
In terms of sort of illustrated material, just a handful, you know, there's only a handful of us, we all sort of know each other. And we're going back to that whole problem of, you know, hierarchy of art forms. You know, as I said, even in mass digitization projects, it's always the words that people are really interested in. Not so much the images. So they tend to be lost in things. And that's what we're trying to sort of resurrect, really, is the importance of the image. And I think most of the work in this field has actually been done on newspaper illustrations as opposed to book illustrations. And the reason for this is because if you think of a newspaper layout, very similar actually to today to what it was in the 19th century.
Yeah.
In that, you know,
It's a lot more structured.
it's structured. There's a very sort of fixed structured. Captions tend to have a specific meaning, appear at a certain part of the so
there's less
it's
variability.
less variability, whereas book illustrations are vast in terms of their variability.
And I mean, in newspapers also have the advantage that you can do studies on newspapers because of history, because they're very useful to understand contemporary history, whilst book illustrations, most people are not interested in society and culture from the 1800s and how influenced us nowadays. I'm more interested in what was talked about on newspapers, for example, rather than in your travel books from the 1800s.
Yeah.
So there's not a lot. I don't think there's been much done on illustrations.
No.
What about the Oxford ballad sheets?
And now that was an interesting project. Goes back a few years now. Again, it's a good example of one that, you know, I don't think any work has been done on it now. But it was called the Broadside Ballads Project, run by Giles Burgle. And that was done in the University of Oxford with their computer science group.
So they have a strong computer vision team there.
Yeah.
So TSC was doing it hand in hand with them. And so they did some quite nice stuff.
They did. It was excellent.
Various versions of illustrations over multiple impressions and alterations over centuries, maybe.
And it was, ballads themselves are sort of, I say, they're relatively limited in number. It's not like a big data set that we're dealing with. So they had a smaller corpus of material, but what they were able to do was trace reused wood blocks. That was a really interesting thing. So you could get one picture that appeared in Broadside Ballad that appeared like 20 years later and had been through various manipulations. So they were interested in, it was reuse, copying. Very interesting. It was called Broadside Ballads. So that was a fascinating project. I don't think anything actually, it didn't sort of develop because really they'd done what they set out to do.
Yes.
And I think it's still available online, probably.
What about Google? They have Arts and Culture. Are you familiar with that website? They also have Google Lens, which recognizes images. What are your thoughts about those two projects?
I haven't really looked into them, to be honest.
I don't know the arts.
Google Arts and Culture is their effort to host great works of art. And so the museum in Amsterdam, it starts with a K, or no, was it Vienna? Kunsthistorisch. I mean, they have great works of art in their reservoir, and then they also have Google Lens, which it recognizes images. But my perception of that, you should try it. But my perception of Google Lens is that it's limited, that it knows the Mona Lisa and will.
So I have used Google Lens sometimes to try to recognize plants.
Yes.
So, you know, work for a walk in the countryside and see a plant. What is that plant?
Yeah.
And I find it very unsatisfactory, actually, because you take a picture, it gives you back, it doesn't tell you what the plant is, it gives you back some alternatives.
Yeah.
And you look at them all, they all look the same to me, but they're all different species.
Yeah.
So I'm no better off when I started and when I finish.
Yeah.
So I'm sure it's good at recognizing some simple things.
Right.
Some very famous things, which there's plenty of examples available online.
But if you're looking for something that's a slightly more subtle sort of question, then I doubt you can rely on it.
Yeah. Well, let's start wrapping up here. I guess my next question is, what questions have I not asked that I should have asked, or that you want me to ask or want to answer? Have we talked about the
such a good job?
No, come on. I have another one then, while you're thinking, if you think of one. Are there any, I mean, you guys have a pretty interesting team here that you put together between English and computer science and your library group. I mean, I think that's a pretty unique thing that you have here. Are there any conditions that made that happen? Is Cardiff University unusual in that way? How did it happen here?
With most of these things, it's individuals, isn't it?
Yeah.
We sort of met.
Yeah.
by some sort of strange.
Yes, semi-randomly.
And I think it's always at the level of the individual. Institutionally, sometimes things are forged institutionally.
Yeah.
But I think for something, this has been quite a long-lasting partnership, certainly that we've had with computer science.
Yeah, so down to individual networking, and it's funny because it's hard to remember how it all started. So there was that connection with Theo, which actually ultimately led nowhere. But sometimes, you have a sort of false start, but even though it seems unpromising, it actually ends up going in another direction, which ends up being much more fruitful, which is what happens in our case. And I guess once you've done that initial contact and things have worked out, then of course you're keen to do some work.
And I would say, though, and I mentioned this earlier on, that from a humanities perspective, I think I have been really fortunate that the computer scientists whom I've worked with have had a real understanding and interest in humanities material. And I don't think that is always the case. But Irene, for example, has, she's really interested and has a really good understanding of visual arts and art history. And Paul is really interested in the history of the book and books and illustrated books. So it isn't always the case that actually happens. So I don't think those relationships are always as fruitful as this particular one has been from my perspective, because I feel as if there is a shared language there. There isn't always a shared language. So,
and what about you? I mean, you have I think you have a courage to wade into these areas. Where did that come from?
I just learned from what they told me. I mean, I could never do it myself. As you've seen, I don't even know how to turn my own laptop on. So I can write about digital things, but actually put them to practice, no. And I couldn't certainly ever do an algorithm that's completely beyond
But you
me.
saw that there was something more that was possible here with all these images.
There's a lot of resistance from a lot of humanists in using digital tools. So in a sense, you were brave in that regard, that you saw the opportunity and actually you went for it. Because a lot of humanists are scared and skeptical of using digital tools. And it's a fair skepticism that they have, because digital tools have been abused because of all the issues with, for example, the inclusivity and the bias in the data sets that then learns into models. And then we try to apply these models to very delicate questions, such as how to trace iconicity of cultures. Obviously the humanists don't want to fall into the trap of making strong assumptions that then lead to like biased outputs. So there is a resistance, but it's important that there is a communication across the disciplines, and like Julia said, a shared language. I think there's not enough of that yet, because digital humanities is such a new field at the moment. There's not enough shared terms and shared knowledge amongst the different disciplines, so that these projects can actually be born. That's what makes it difficult, I think. What I mean as bias might not mean the same for Julia.
But the more I sort of look into this sort of digital world, I am increasingly struck by the similarities between the digital world and what I would say is the 19th century illustrated world. The way that readers have to negotiate between pictures and words, as they did in the 19th century, I think is exactly, it's very similar to the mode of reading that we engage in today. When we look at a computer screen, we're always juggling between images and text. And I think that particular way of reading came about in the 19th century with the explosion of illustrated material. People had to learn to read in a radically new way, and it's we take it for granted today. When we look at a computer screen, I mean, I'm here looking at your beautiful database, and I can see, the title, I can see words there, I can see pictures. It's bimedial in the same way that the Victorian world, the 19th century world, was bimedial. So I'm struck by those parallels.
I'm working with a teacher named Graham Senior, and he talks about visual literacy and teaching students how to consume images, how to be critical of images, but understand what's in an image. But what did you use the word bimedial?
Bimedial.
Bimedial.
I mean, obviously today you've got animation and sound as well.
Multimedia.
But I would still argue that the key is that relationship between words and pictures.
Yeah. Okay, well, that sounds like as good. Eleanor, anything to add or any questions? No? Okay, well, thank you very much. I really appreciate all of your time.
Thank you.
Thank you.
Smith's stuff sounds interesting. I don't know if I've seen that. What can you give me the details of the?
Yeah, I'll send you.